Okay, afternoon everyone. We're going to go ahead and get started. A couple announcements. Today is the last day to turn in Unit 8 homework. So check Skyward if you're missing some homework assignments from Unit 8. That's our previous unit on exponential functions. If you're missing homework from that, try and get those in today. Get yourself some points back. It helps your grade. Having a bunch of 10s is a lot better than having a bunch of zeros, okay? It's an easy way to keep your grade up. Unit 9 homework, you should be able to finish 1 and 2 if you haven't already. Those should be, 1 should definitely be finished by now. 2, that's on graphing, you should be able to get that one all the way done. You should be able to at least start number 3 tonight. You're staying on top, I would recommend staying on top of it. It'll help you stay on top of the material as we get ready for our test. And our test is next Thursday. Test next Thursday. It's doubling as Unit 9 test, and also it's going to have some material from previous units. It's kind of a midterm, so it's going to have some stuff on systems and some exponential stuff. So Unit 9 test next Thursday. Take a note of that if you want, okay? So all that aside, we're going to start with some bell work today. So copy down both these equations, and we're just going over transformations in a logarithmic function. So what I want you guys to do is I want you guys to find the A, the H, and the K for both of these, and then write out what the transformations are. Okay, so like left or right, however much, up or down, however much, okay? So take 2 or 3 minutes, get started on that, and then we'll go over it. This reflect over x or y axis?
That's x.
Yep. All right. So if we've gotten a start on this, so let's take a look at this first function, the 2 times log base 3 of x minus 5 plus 3. All right, so A, that's that number multiplied out front, right? So what's our A? 2, yeah. Oh, wrong color. 2, all right? How about our H? What's our H? It's in here. Is it negative or positive 5?
Negative.
I'm hearing both. Positive. It's positive 5. And that's because our base form is x minus h. Right, our base transformed form has x minus h. So if we have x minus 5, h has to be positive 5. If you do minus a positive, it stays subtraction. But if you did minus a negative, it would switch to addition, right? And then our k. What's our k? That's that 3 at the end, yep. Okay, so A is 2. What's that going to do to our graph? What our A? A is 2. It does something. Stretch. Yep, vertical stretch. So when that number out front is bigger than 1, it's a vertical stretch. Just like with our exponential functions, these are all the same, right? H is 5. What does that do? 5 to the right, yep. Right 5. And then K is 3. Up 3, yep. Okay. So over here, the second function. What's our A? Negative 1/2. Yep, very good. Negative 1/2. How about our H? Negative 4. There you go. Negative 4 because it's x minus h, so x minus negative 4 is x plus 4, right? And then our K at the end? Negative 2. Yep. All right. So our A is negative 1/2. That's going to do two things. What's one of them? So it's not stretching this time. What's the opposite of stretching? Compresses, because that number is less than 1, right? That absolute value is less than 1. It's a fraction, so it's going to compress instead. So vertical, it's going to write vert, compress. And it's also negative. What happens if our A is negative? Reflects, yeah. Reflects over which axis? X-axis. Reflect, I'm writing too big. X-axis. And then we have an H is negative 4. What does that do? Yep, left 4. And then our K is 2, or negative 2, excuse me. Negative 2. Down 2. There we go. Down 2. All right. Hope that all feels pretty familiar. Feels pretty. Nothing seems crazy, and you've never heard of that before. This is the same stuff we did with the exponential functions. Just want to touch on it one more time with our logarithms. Still looking for AHK. Those transformations, those numbers, they still do the same thing to our graph. So you don't need to learn different transformations as you're studying for your tests, okay? Any questions about how we got any of these or what these transformations do? Okay, cool. Let's move forward then. So the last couple of days, we've been graphing logarithms. We've been making a lot of good progress there. And we'll be able to touch on a little more as we study for our test, but today we're going to move forward and we're going to start evaluating a logarithm. So if we get a logarithm with a certain base, a certain number attached to it, how do we find what that value is? How do we find what the value of the logarithm is? So we're going to build a couple rules that we can lean on, and then we're going to go through some examples, and then we'll work on them, okay? So flip to page 122, please, of your Agile Mind books. Alrighty. So we're going to start with some review of some exponent rules, because we've been emphasizing that there's a connection between exponents and logarithms, right? Because they're opposite or inverse, so they relate to one another. They relate to one another. We got this up here. This is how your exponents relate to your logarithms. We'll be relying on that some. Okay? So let's think. So for all of these right here, b is just any number, right? And m and n, m or n, can also be any number, okay? So b is any number, and b in this top one is to the 0 power. If we remember from our exponential tables, from our calculators, excuse me, if you take a number to the 0 power, it always equals something. Does anyone know what that is? 1. Yep, very good. So b to the 0 always equals 1. All right? Now these next few might take you back a little further. You may not remember them. That's okay. That's why we're reviewing them. So if we have two numbers with the same base but different exponents, and we multiply them together, so like 2 to the 3rd times 2 to the 4th, for example. What do we do if we have a circumstance like this. Does anyone remember what we do to see the exponents? See? You add them. Yep, you add them together. So b to the n times b to the m equals b to the n plus m. Hopefully that's, yeah. All right. So next one, b to the n divided by b to the m. Division's kind of the opposite of multiplication. So with this one, it would make sense to do the opposite of addition, right? So in this one, we're going to do, so when you divide them, it's b to the n minus m. Okay? And then last one, we have b to the n, all of that to the m power. And this one is b to the n times m. Okay? We're really only going to need this top one today. We might rely on these other ones later. But just get those down, just to review, refresh your brain on some of these rules. Because there's a connection between all these and different rules we're going to find with our logarithms, okay? All right, so we're looking at number 2 now. This is how we're going to build one of our rules that we can use. So we have the statement. We just remembered that b to the 0 equals 1. All right? So you have that statement. Now we're going to rewrite it as a logarithm. We've got this up here. So a equals b to the x power. That's the same as the log with the base b of a equals x, okay? That equals the exponent. So you can do an arrow or something, whatever you want. So we're going to rewrite this as log, the base of our exponent is b, so that goes down here, log b of, and then the number that our exponential is equal to goes right here, equals the exponent. And this is a rule. This is always going to be true. Something we can use and we can remember when we're evaluating, okay? So if you see any logarithm to any, b is any number still, logarithm with any base of 1, it's always going to equal 0, okay? So that's something we can always be looking out for. All right, this next one. Now we have the statement b to the first equals b. And we know that's true if we remember our exponential tables. 2 to the first power was always 2. 3 to the first power was always 3. Anything to the first power is that same number, okay? So same deal. We want to rewrite this in a logarithm. Use the same idea. All right, so take like 30 seconds and try and do it on your own. Try and make a logarithm, like how we did up here, but now you're using this statement, okay? Look up here for help. See if you can make it. It's fun. Maybe. I don't know, but still try. You don't need to keep that exponent. You just be b. Yep, just a b. Do you want to write it on an iPad for me? Sure. Okay. Yeah.
Gotcha. So wait, what is it? I'm not doing that.
Yeah.
Oh.
John wrote it up here on the iPad. He's got it right up here. You compare it with what you thought of, or you copy it down. Okay? So we've got another rule right here. So if we have a logarithm with a base of the same number as the base, that always equals 1, okay? We know that because we know b to the first power equals b. Okay, so we've got two rules now that we can refer back to and in particular circumstances with examples, okay? So we've got these two. Give you guys 30 seconds to copy anything down that you're missing, and then we're actually going to go back one page in our books, okay? So, okay, yeah, we seem ready. Let's go back one page. Got a few things to read. You guys can write in, so I'll give you guys a couple minutes. Give you guys a couple minutes to write this stuff in. If it's not clear, this is an A. This is an A. Both those are A's. I typed them in as B's, but I switched them to A's so it would be less confusing. So, copy some stuff down, and then we'll talk about it. All right. You still need to write some stuff in. Keep writing. I'm going to start talking about this stuff. Okay? Let's talk over a little bit. Okay, we're going to start at the top. We have two kind of main logarithms that we always want to that we're always going to refer back to. One is the common and one is the natural. Okay, let's start with the common. So our common logarithm. For whatever reason, the math people in charge of math, they decided that a common logarithm is going to have a base of 10. It's always base 10. Maybe it's because it looked nice, 10, 100, 1,000. Maybe they just liked that it was aesthetically pleasing, but that's what they chose it as. Okay? So a log with base 10, it's just like any other logarithm, except this one you can do in your calculator. Okay? So our common logarithm, it's in your calculator. That's the log button. Okay? That's the log button. It's right underneath second in the top left corner. All right? On your calculators, if you got a calculator, it'll be helpful for evaluating. Okay? So common logarithm, that's the one on your calculator that says log. So those are ones that we can do in our calculator. And if you see one that's written, and it's most often you're going to see it written as log of A. If you see a question that says log and it has a number, but it doesn't have a base, it doesn't have a little number here, then we can assume that that's a common log, and the base is 10, and it's one that you can do in your calculator. Okay? So if you just see log of 6, that's a common log, okay? Common logarithm. Okay. A natural logarithm is the other one. So natural logarithm, that is a logarithm with a base of e. That's that same e that we used last unit for compounding continuously. Okay? Again, I don't know why they picked it. They just did. It's just my job to teach it to you. Well, not really my job yet, but soon. So log with a base of e of any number, that's our natural logarithm. Most commonly, you're going to see it written as ln of a. So if you look again on your calculator, find that log button, right underneath it, it should be an ln. That's a natural logarithm, okay? That's another one you can do in your calculators. So if you see, for example, ln of 7, you can just put that in your calculator and you get the answer, okay? So common log, base 10, log of a number, natural log, log with a base e, that's ln. That's another one you can do with the calculator, okay? We've got them written here. I wrote them over there. ln, log, you can use a calculator for those, right and easy. Nice and easy, okay? How do we evaluate a logarithm? We've kind of talked about it some. Really what it's asking is, what is the exponent I need to get one number to equal another number, okay? What is, like here? What is the exponent that I need to make 10 equal a? Okay, it's asking what's this number here? And I just realized in 5th period that this question is not grammatically correct. Hopefully the idea comes across. What is the power of the b that gives us a? Instead of that, but that's okay. Okay, so this is always, if you're struggling conceptually with a log question, you can always remind yourself, okay, it's asking for this exponent, all right? And then last thing is down here. This is our third rule or trick or technique, whatever you want to call it, that we're going to talk about today. This is our change of base formula. And this essentially puts, you can put any logarithm into terms that we can use our calculator for, okay? So you can see that it's just got a normal logarithm with a base, any base, any number attached to it, any a, and all we have to do, that is equal to the common logarithm of a divided by the common logarithm of b, okay? So this and this are both ones you can do in your calculator, right? And a way we decide to remember which one goes on top, a is in the attic and b is in the basement, if you ever forget, okay? So if you know, come with little sayings like that help you, a's in the attic, b's in the basement, okay? So it's pretty straightforward. We'll do an example to make sure it makes sense more concretely, and then we're going to do one example with that, and then we're going to do another example, and then I'm going to turn you guys loose, okay? So, number 1, right below, I'm going to walk us through this one, and I'm going to walk us through one more, and then I'm going to let you guys try your own at the rest of them, okay? But we're going to look at number 1 first. Okay, this is a logarithm. It's got a base. You see that base is not 10, it's not e, so we can't do it in our calculator right away. Our base is 5, and our a is 12, okay? So first, I'm going to think about it conceptually. What is this asking? I'm going to set this equal to x. So it's asking 5 to what power equals 12? That's what this question is asking. What exponent do I put on 5 to get it equal to 12? So again, if you're ever just kind of forgetting what a logarithm is, and it just seems like some weird random thing, you can always refer back to that to remind yourself, okay? So now we're looking, so we have a base, we have a number, we got to do our change of base formula to solve this one, okay? So our b, that's our base, that's this little number, that's 5. Our a is 12. So all we do is you do
common logarithm 12 divided by common logarithm of 5. And that's what you can do in your calculator, right? If you have a class calculator, I would highly, highly recommend using the fraction button. That's the one that looks like n over d. The log button is right below second in the top left corner. So you just press the fraction button, do log 12, use the down arrow, move down, log 5, enter, that should get you your answer. If you don't have a class calculator and you can't do a fraction button, do division instead. Do log 12, close your parenthesis, divide, log 5, close your parenthesis, that should get you your answer, okay? So I want everyone to practice putting this into your calculator. It's definitely an important skill to keep developing. So everyone give it a shot, and if you have any questions about the calculator, let me know. I can come around and help. Okay? So go ahead and try your hand at this one, and then we'll come back together, go through one more, and then, yeah. Yep, that's it. Yep. Cool. Oh, yes. A lot of your answers are going to be decimals. Round to the second decimal place, please. The hundredths place. All right. I'm going to keep going. And then, so I want to go over one more, and that's number 6. Number 6, we have ln of e. So we have the natural log of e. All right? So this one's a little trickier to put in our calculators because e has to have an exponent, okay? But this one's actually going to be really easy, okay? We just got to think about what this means. Natural log, we just talked about it. That's a logarithm. What's the base of a natural log? 10's the other one. Check back in your notes. What's the base of our natural logarithm? It's e, yes. So a log with a base e of e. Now that looks like something we talked about, right? Does that look like one of our rules? The base and the number are the same? What does that equal? 1. Yeah, equals 1, okay? So ln of e equals 1. That's going to be a fact that you're going to end up memorizing whether you want to or not. Natural log of e is 1, all right? Okay, you guys have plenty of time. I want you all to do the rest of the examples on that page, okay? Practice setting it up, practice putting it in your calculator, round to 2 decimal places. I'll be around to help you with any questions. And if you finish that, go ahead and get to some homework, okay?